In a previous video, we got JupyterLab up and running, created our first notebook, and confirmed that everything was working. But I didn't spend too much time on why I'm using JupyterLab, or why I think it's the right starting point for a business professional who wants to expand their data skills with Python. This channel is focused on Python for people who work in business, analysts, marketers, operations managers, and anyone who lives in spreadsheets and wants to do more with their data. You won't find computer science theory here. The goal is practical skills you can apply to the kind of work you're already doing. In this video, I want to make that case. We'll look at what makes JupyterLab a practical starting point, how it installs, how it handles documentation, and how it supports the kind of exploratory work that's common in business analysis. Along the way, we'll pull in a real-world data set from the Federal Reserve, the inventories to sales ratio. This is the kind of data that many businesses track. And by the end, we'll have a working chart all within the notebook. No CSV files, no manual downloads, just a few lines of code. Before we write any code, let me explain what I look for in an IDE, especially one I'm recommending to someone who hasn't written code before. The first thing I care about is setup friction. If getting started requires visiting multiple websites, installing separate applications, or configuring things before I write a single line of code, that's a problem. JupyterLab doesn't have that problem. We installed it with a single pip command in our virtual environment, no separate installer, no license key, no external website to navigate, and that matters. The second thing I care about is whether the tool requires extensions or plugins to do basic, useful work. Some IDEs ship as a minimal core, and you spend the first hour figuring out which extensions you need. With JupyterLab, you're ready to go the moment the browser opens. And the third thing, which is maybe the most important for the kind of work we're doing, is whether the tool supports the workflow of exploratory analysis. That's where notebooks really shine. And it's why platforms like Google Colab and Coursera's data science courses are built on the Jupyter Notebook framework. If you've used either of those, you already have some familiarity with what we're working in. Here's something I think gets overlooked when people talk about notebooks. A Jupyter Notebook isn't just a place to write code, it's a document. You can mix code cells with markdown cells, where markdown is a lightweight formatting language, where you can write headings, bold text, add bullet points, and even display formatted equations, all alongside your code and its output. Let me show you what I mean, and I'll add a markdown cell to this document. When you run that cell, the markdown renders. It becomes formatted text, not raw syntax. That means someone reading this notebook sees a clean, structured document, not just a wall of code. This is what makes notebooks useful for reproducible documents. You can write the explanation, run the code, and see the output, all in the same file. And you can share that with a colleague who doesn't have Python installed. I'd like to point out that JupyterLab has two built-in tools that make it easier to write code when you don't have everything memorized. And when you're just starting out, that's pretty much always. The first is tab completion. When you're typing a function name or a method, you can press the tab key, and JupyterLab will suggest completions based on what's in your environment. Here, I'm going to type pd dot, and I can see the drop-down of available methods. This is especially useful when you're working with a library you haven't fully memorized yet. You can use the arrow keys to navigate and enter to select. The second tool is inline documentation. Position your cursor inside any function or method name and press Shift and the Tab key. You'll get a compact tooltip showing the function's documentation right there in the cell. If you scroll down in these tooltips, you'll often find useful examples. This is the approach I use most often in practice. It's quick, it's reliable, and it doesn't require opening a separate panel. JupyterLab does have a full contextual help panel available under the Help Show Contextual Help, but I find Shift plus Tab sufficient for day-to-day work. For full API references and detailed examples, the official library documentation is always the authoritative source. Now let's put the environment to use with something practical. I want to pull a real economic data set, the kind of data that's relevant if you work in supply chain, manufacturing, or finance. The data set is the Manufacturers Inventories to Sales ratio with the FRED series code MNFCTRIRSA. This comes from the Federal Reserve Bank of St. Louis. It's a seasonally adjusted monthly series that tracks the ratio of manufacturer inventories to sales. When this ratio rises, manufacturers are holding more inventory relative to what they're selling, often a signal of a slowing demand. FRED publishes its data as public CSV files, and pandas can read a CSV directly from a URL using the read_CSV. That means we can pull this data with just pandas and no additional package is required. So let's start with adding the URL as a variable. One important caveat: this CSV URL is not an officially documented or supported endpoint. FRED hasn't advertised it as a stable interface, so the link format could change at any time without notice. If you find it stops working, the FRED website is always available for manual downloads, and there are dedicated Python libraries that access FRED through its official API. For now, it works cleanly and it keeps things simple. I've separated the URL into its own cell deliberately. As you explore the data in the cells below, you won't accidentally rerun the network request. Just reuse the URL variable when you need it. We start by using the URL as an argument inside the read_CSV method, and we can take a look at what comes back. You can see that the data has two columns: the observation date and the FRED code that we provided above. One problem: the dates are coming in as strings at this point, which we can confirm by looking at the data types. Here, the observation date column is shown as a string, and the data frame is an object. We need to convert that to a proper date type before we can use it in a chart. Rather than doing that in pandas, we'll convert this to a Polars DataFrame and handle the type conversion there. You might notice I'm using the _df in the variable name. This is just to make it clear that this is a data frame. It's a convention I'll follow throughout, so it's easier to identify what each variable holds. And I'm adding 2 to the name for the Polars version, which also helps with tab completion when you're working interactively. So let's convert this to a Polars data frame and convert the observation date to a date time. Now let's confirm the date column is correctly typed. The observation date column now shows as date time. Polars has converted it from a string to a proper date type, and let's look at the full data frame. Good. We have a clean data set with a proper typed date column and a single value column. Now let me show you why that date conversion matters. We can pass this data frame directly to Plotnine, no conversion needed, and produce a line chart. I do need to import several functions from Plotnine. Here, ggplot, the aesthetics function, and the geometric object geomeLine. Then, with 2 lines of code, I can create my plot. Because the observation date column is a proper date type, Plotnine renders the x-axis with correctly formatted date labels automatically. If we had left it as a string, the axis would either fail or display incorrectly. This is a preview of where we're headed. In the visualization videos, we'll build on this foundation, adding labels, adjusting themes, and producing charts that are ready to share. For now, the point is that in just a few lines, we went from a data source to a properly formatted chart, entirely within the notebook. Before we start this next section, a quick note. The PDF setup I'm going to walk through is specific to Windows. If you're using macOS or Linux, the same general approach applies, but the installation steps and tools will differ. If you go to File, then Save and Export Notebook As, you'll see several options. Let me start with HTML, since it requires no additional setup. You can simply select HTML, and JupyterLab will save a fully rendered version of your notebook, code, output, and markdown, into a single file. Now let's open that file. In Windows Explorer, navigate to the Downloads folder, find the HTML file, and then you can right-click and choose Open with your favorite browser. Here, I'm using Microsoft Edge. Edge renders it cleanly. It looks essentially the same as it does in JupyterLab. You can scroll through the notebook, see all the output, and share this file with anyone. They just need a browser to open it. If there's a limitation, it's that most people aren't used to receiving HTML files as attachments, and that's where PDF comes in. First, it's relatively simple to simply print this HTML file as a PDF. But there is another method. PDFs can be a bit more involved, and I want to walk through the setup so you understand what's happening. JupyterLab's PDF export works by converting your notebook to a format called LaTeX or LaTeX, and then compiling that into a PDF. To do that, it needs two things installed on your system outside of Python: a program called Pandoc, which handles the document conversion, and a LaTeX distribution called MiKTeX, which does the actual PDF rendering. The good news is that we can install both of them the same way we've been installing everything else in this series, with winget from the terminal. I'm going to close my Jupyter Notebook for now and open a new PowerShell window. And then enter these two commands. First, I'm going to install MiKTeX. Depending upon how your computer is set up, Windows may ask for permission to make changes or for you to enter your administrator credentials at the installation, and then it will proceed. We can then install Pandoc. Both of these are system-level installs, so they go outside your virtual environment. This is similar to how you installed Python. Once complete, close and reopen your terminal so the path updates take effect. You can verify both are available with the following commands. There is one more step. MiKTeX installs a minimum base and then downloads additional packages on demand the first time it needs them. To avoid getting interrupted mid-export with installation prompts, let's tell MiKTeX to handle that automatically. We need to open the MiKTeX console from the Start menu, go to Settings, and set Install Missing Packages on the Fly to Yes. This is a one-time configuration. Now we're ready. Let's go back to JupyterLab, and now go to File, Save and Export Notebook as PDF. The first export may take a few minutes. MiKTeX is downloading any remaining packages it needs in the background. After that, export should be faster. The PDF that comes out is clean, properly formatted, and handles everything, including mathematical equations. And this is without any extra work on your end. It's a one-time setup cost for a result that holds up well. A couple of housekeeping points as we wrap up. JupyterLab auto-saves your notebook periodically, but it's a good practice to save explicitly. Control+S will do this, and your notebook is saved as an IPYNB file. When you're done for the day, don't close the browser tab. Go to File, Shutdown. This closes the Jupyter server running in the terminal. If you skip this step, the server processes stay running in the background until you close the terminal window. So to summarize, what makes JupyterLab a practical starting point? It installs with pip, it works without extensions, it supports a mix of documentation and code in the same file, and it integrates cleanly with real-world data sources. None of that requires you to be a developer. It just requires a working virtual environment and a willingness to run some commands. If you found this useful, consider subscribing. I'll be publishing more videos focused on building practical Python skills for business and marketing professionals. And if you'd like to go deeper, I've written a companion book, Getting Started with Python on Windows 11, that covers these topics in more detail and includes additional examples and exercises. I'll include a link in the description. I look forward to seeing you in the next video.